So we found we have found the two prime implicants T prime and R prime. Both of those are of size 4, and if we look at the Carnot map, we can clearly see there are no more prime implicants of size 4, and so then we go to size 2, and indeed there are groupings of 2 that are present, but no grouping of 2 is present which is not already entirely contained with one of the previously identified prime implicants. And likewise, the same can be said for any groupings of 1. So the 2 prime implicants, T prime and R prime, are the only prime implicants. And so now our next step, as usual, after we have found all of our prime implicants, is to identify which of the prime implicants are essential. So we'll say essential prime implicants. And of course, the way to identify these is by identifying the essential 1 cells. I encourage you to take a moment to try to do this yourself, but the essential 1 cells will be here, 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 and here. The only 2 1 cells that are not essential are the one in the upper left-hand corner and the one in the upper right-hand corner. Both of those 1 cells are common to both of the prime implicants. So now that we have identified the essential 1 cells, we ask ourselves which prime implicants are essential. T prime is essential because it has this essential 1 cell and this essential 1 cell. And the R prime implicant is also essential because it has these 2 essential 1 cells. Therefore, both of the prime implicants that we have found are essential. And now we look for minimal sums. And this function is F3. So F3 of R, S, and T. We write down the 2 essential prime implicants, T prime or R prime, and by including T prime, we have accounted for those terms and these terms, and then by including R prime in this sum, we have also accounted for those terms. And again, as in all our previous examples so far, by merely including the essential prime implicants, we have accounted for the entire function, and therefore this expression is sufficient. It is the only minimal sum for this problem. And note that here we have 2 literals. So we have gone from, by using the Carnot map technique, we've gone from an expression with 6 literals to an expression with 2 literals. And 2 easy ways that you could show that these expressions are equivalent would be to find the truth table for each expression and make sure that the 2 truth tables are the same, or by algebraic methods you could fairly easily show that the second expression is equal to the first. So that concludes all of the examples for lecture 11, and now we'll look at some problems. So the 2 problems for lecture 11 are shown here. 11.1 says find all minimal sums of f of xyz equals the sum of the min terms 1, 3, 5, and 7. And your choices are these four choices. 11.2 says find all minimal sums of g of xyz equals the product of the max terms 2 and 4. And here you have these four choices. So that concludes lecture 11. Good luck.